Hello, this video is about making 3D shapes that may or may not be flexible. Welcome, my name is Caroline from Bubbly Maths and I'm presenting activities by AIMSEC that can be found on the Aiming High website, on the Aiming Eye website. I'm just going to, if I can find it, put a comment in the comments with the link as soon as it comes up. I'm just waiting for it to come up and I'll do that. So in the meantime, I'm going to now share the visualizer so that you can see how we're going to make flexible shapes. Now this activity is suitable for 7 to 18-year-olds. There'll be a separate activity that's for early years and you'll have to make the paper sticks for the younger ones, whether you're grown up, whether you're a teenager or younger. You can, a lot of you can make the paper sticks yourselves, and there's a video, separate video, which the link will be here to that as well. But oh, here it is. Say something. No. Ah. Okay. I know what the problem is. Can't say anything. I'll put it in later. I'll put in the activity later. So, going to switch screens and share the screen with my lovely mess. Look at all my lovely paper sticks. Love them, absolutely love them. They're so versatile and flexible, and yet they're not. So there's something, don't know what it is yet. There's something else that I made. There's something else there. And here's lots of lovely individual paper sticks. Instead of knitting, I spend my time making paper sticks in the evening. Doing that this morning. So let's put those aside because this is something I made earlier. The question is, oh, let me just stop sharing that one and I'm going to ask you a question based on sharing. Okay, it's going to be here. It's going to be here somewhere. It is here. Based on these shapes here. So looking at this cube, is it flexible? Is this one flexible? In other words, can you change its shape? This is tied up very tightly, but if it's tied up tightly, can you change its shape? Or does it stay rigid? Does it stay the same? Oh, you can't see it, sorry. Does it stay the same shape? I was doing it on the visualizer. I think I've got 3 screens and I only have 2. Does it stay the same shape? That's the tetrahedron. Now I've got all these other shapes. So let's just, now that you're looking at those shapes, I'm going to go back to the visualizer. And now you can see this. So you've got the tetrahedron, but even if you squish it down and do different things, it stays. Okay, it's a bit, I've done this a few times this morning already and it's starting to fall apart. But if I'd done my knots more tightly, it won't change. And I've got this one as well. This one's one I made earlier. That you can't squish it down. You can't squish it. You can't squish it that way or that way. That's a rigid shape. What about this one? What about this shape here? You recognize that one? It's a cube. And look what happens if I bend it sideways. It's become 2D. And look at the shape if I lay it flat. And you can even fold it over, make it into a square, and then you can squish the square into a rhombus and even into a straight line. And there's lots more things you can do with that one. So this is really flexible. Every edge is rigid. These vertices are not rigid. You can get cubes, like I've got cubes that I do my bubbles with, that are basically the rigid vertices, but naturally occurring, you can, if you're only looking at the edges. So this is an examination of the edges, just a very little, not so little point here. These are just the edges, so it's like the skeleton of a cube. So if it was a proper polyhedron and it had, every face was actually a 2D shape, then you wouldn't be able to squish it into, flatten it into a rhombus or a straight line, because its 2D area is set. So if you wrap this up in some solid cardboard, or put solid cardboard, you know, nice rigid cardboard in between all these spaces, all these edges, then it wouldn't collapse. And you couldn't even, it wouldn't collapse that way either. But as you can see, it's not a stable shape. It doesn't inherently stay stable. So that is a very flexible shape. Oh, look, now I've even got, it's folded into 3 sticks. So now, what about this shape here? That's from one of the choices on the list. It's coming apart. I'd tie them loosely so that I don't waste the paper sticks, so I don't waste the resources, and then they just come apart. So, right. Oh my goodness, you've seen it. The surprise is spoiled. Oh my goodness, what happened to that? Maybe by untying it, I ruined it. But wait, no. If I sit it on the square base pyramid, if I sit it on the square, it stays stable. Something about its shape allows it to stay stable. But if I move it over, then it becomes 2 triangles. And I discovered some more earlier as well. What was it? Something that was rather lovely. Don't know how to do it now, but there was another shape that I managed to find that was a big surprise. Let's see if you can find all the different shapes that this square base pyramid can become. I don't know how I did it now. There was something. I don't know how I did it. Oh my goodness. It was very interesting, whatever it was. Okay. So this is not fully collapsible. So there are questions on the resource. Now the resource, I'll stop sharing this one and go back to sharing this one again. There we are. And so you can build all of those and find out. Now, depending on how old you are, you can just have someone help you build them. But it's really good to imagine first which one of those you think are going to collapse and which one you think is going to keep its shape. So when you look at them, decide that before you make them, and then make them. And then you might think of some other shapes to make. So, and then as you get older, there are more. This activity is what they call low threshold, high ceiling. So there are activities on this same activity sheet that are suitable for early years as well. So this one thing actually covers all the way from ages 4 to 18. I just do a separate video for the early years one. So download this and just follow the activities, how to make a paper stick. There's a link, there's another YouTube video on how to make paper sticks. And then there's lots of questions. So we're looking at, for early years, you're looking at the basics. For primary, we've already covered what you can do with it. Lower secondary, you want to be asking more questions. The questions are all on here. So which ones do you think will we be rigid? How about recording, it being systematic? I'm just going to move on down. There's so many questions on here. Follow the questions through and you'll learn so much about geometry, and it'll ignite your curiosity so that when you're in class, then it will be more interesting for you. And while we're doing the activity, we want things like, we want to be systematic in searching. So you can start with a tetrahedron, which has, let's have a look. I'm going to just go through this, visualizing 3D shapes. But let me actually, no, can I do that? I'm just going to just basically read through this. It's about testing. It's about having predictions, testing your predictions, being enthusiastic about you don't have to be right, because if you predict it and it comes out wrong, it's like doing a scientific experiment. Scientists have to do experiments. I will actually stop that. Scientists have to do hundreds, sometimes thousands, sometimes there's a whole people all around the planet doing experiments to find cures and find solutions and find out new things about things. When a scientist does an experiment, They don't think, oh, this better be right, and if it's not right, I give up. I'm wrong, and I must be something wrong with me. I'm maybe not clever. Scientists know that, and mathematicians too. There are mathematical problems that haven't been solved yet. They're out there, that someone's thought of a problem, and no one yet has found a solution. And mathematicians get interested in a problem they don't know how to solve, and scientists get interested in a problem, especially ones that no one knows how to solve. There's so many scientific problems that no one knows how to solve yet, or improve them, and you don't get to the answers by getting it right because no one knows. So you get to the answers by getting it wrong many times, until finally someone goes, oh, look, this works. And then someone else might come on later and find something that works even better. And that's the way we learn. That's the way we develop. So we're going to look at this shape here. We're going to start being systematic, and we're going to record what we're finding out. Well, we want a name first. Well, you can call it a triangular base pyramid, because all pyramids are named according to the shape of their base. The other one was a square base pyramid. It has another name. We're going to call it, I'm going to write it here. There you go, tetrahedron. So that one's got, call it a tetra there. It means, has a meaning, it's an ancient Greek word, and it means, that part there means 4, and that part there, I don't know if it's singular or plural, but I'll call it faces, because that's how we use the word. It's got 4 faces, and so it's called a tetrahedron. Let's make sure. Let's see if it does have 4 faces. 1, 2, 3, and then underneath 4. It's got 1, 2, 3, 4 faces, tetrahedron, or triangular base pyramid. You can always name a shape. If you don't know the name of it, you could investigate it, but you can always call it by the amount of faces it's got. That is something you can always call it. That would be just a way of doing it in English. And the point is, you can then find out. If you don't know the word and you want to write a name, you can just give it that name, because polyhedra that are made up of 3D shapes that are made up of 2D shapes are solid 3D shapes that are made up of 2D shapes are all named something hedron, as long as they're made up with polygons. And just one little thing, this is not a polyhedron, because polyhedron is a solid. Its faces are actually 2D triangles, so there isn't this gap in the middle. These are, we call them the skeleton of a polyhedron. So you're only looking at the edges, and that's how you can find out if they're flexible or not. So this one wouldn't actually collapse if you had if everything was actually a 2D shape, but they had a bit of cardboard on bottom and a bit of cardboard on these 4 faces, it wouldn't collapse. But it does show you which shape is more stable, even if they have all the faces. So in an earthquake, or in a building or a bridge, which shape would you base it on? Lots of triangles or not so many triangles? That's one of the structural engineering, that is. Right, now 4 faces, how many edges? Well, I like, especially this one, I'm always looking for the symmetry, I'm looking for patterns, which is a very mathematical thing to be doing. And what I find, this one, it has a tripod, 1, 2, 3, so 3 legs, tripod, 3 pod legs, and it's got a triangle on the base, and that's all there is. It's a tripod, 3 legs, and a triangle on the base. So it's got 3 and 3, that's 6. So it's got 6 edges. How many faces? Well, we know what it's called. We know it's a tetrahedron, and we know tetrahedron means 4 faces, but let's check. 1, 2, 3, 1 between each of the tripods, and then the triangle at the bottom is the 4th. So that's 4 faces. How many vertices? Well, a vertex are the pointy bits. So let's count them. There's 1, 2, 3 around the triangle, and then 1 that joins all the 3 tripods together. That's 4. So, and then The final question is it flexible? Well, this shape is not. This shape, you can throw it, you can bounce it, unless you actually break it, it's not. As long as the edges are rigid and the faces are intact, it's not flexible. So no, you can go and do that for all the other shapes in the activity, and you can do it for, you know, think of your own. So first of all, visualize whether or not the shape you're going to make, do the one in the activity, decide which ones are going to be flexible, decide if some are going to be semi-flexible or collapse completely down, like the cube, and have a good play with the cube. There's another activity and there's a link. When I put the link in, I'll put the link in the description as soon as it finishes. And it's a whole section on the collapsible cube, which is lovely. It's a separate video. Oh, that's a video on our sister channel, Maths Toys. Right, I think that's it for today. Thank you very much for joining. And I'm going to see if there have been any comments. What I've done is I wasn't signed into the right account, which is why I couldn't actually write in there, but I can see the comments, I think. Maybe not, maybe I should be able to. No, I can't see any comments, so that's grand. Thank you very much for joining us, and I will see you with posting lots and lots of tunes. Please do, if you like the videos, give us a like, subscribe to the channel, it's Bubbly Maths YouTube channel, and ding the notification bell so that you find out every time we upload a video. It'd be great to see you next time. Thank you. Bye-bye.